Hi, we are a group of 7 members of doing a mini project called Solidwork of Quadcopter. And next, I'm going to introduce what is quadcopter. Actually, quadcopter is called as drones, and drones have evolved over the years and become a perfect flying machine nowadays. To make sure a drone functions well, its mechanical design aspects are very important, and each methodology listed have their own function. In this mini project, we're applying the features of SolidWorks, and a drone is designed perfectly.
The objective of the mini project is to demonstrate the detailed design of the quadcopter and to demonstrate how the quadcopter works.
Hi, my name is Ong Chun Hau and my register number is J20A0607. So today I want to present about methodology. First part is part 1 is spider base, part 2 is spider top, part 3 is spider arm, part 4 is battery, part 5 is spinner, part 6 is sparker, part 7 is electric conductor, and part 8 is repeater, fan, part 9 is fan, part 10 is motor, part 11 is distribution board, part 12 and part 13 is electric units, and part 14 is sub-assembly electric board, and part 15 is final assembly. And this is a part 1, spider base. So first we use a top plane, sketch a diameter 70 mm, 25 mm, 82 mm, and 120 mm. Then after that, we execute in width 10 mm thick. Then by using top plane, then sketch a diameter of 12 mm and 50 mm. After that, we draw 3 mm circle. Then we use extrude it with 2 mm thick. After that, we use fillet to do 4 2 mm circle. After that, done. Spider base. After that is the part 2, spider top. So also same, we use top plate. Then after that, we use diameter 70 mm, 25, 82, 120 mm. Then after that, we use 10 mm. Then after that, we sketch the diameter 50 mm, 3 mm, 10 mm, 6 mm, radius 2.8 radius. After that, we use mirror to sketch out other part. Then after that, we use extruder cut to cut out the base, the shape. Then after that, we sketch a diameter 35 mm and 30 mm. After that, we extruder cut to cut out the shape. Then done. This is by the top.
Assalamualaikum warahmatullahi wabarakatuh. My name is Bibi Intishaar Binti Hakim. My number is J20A0425. It is my turn to present my part, which is spider arm. Okay, I produced this spider arm with the right size so that I can produce a perfect drawing. After pressing the extruded pause button to produce my sketch into a 3D drawing, this is the result. To make it more interesting, I added color to the spider arm to look more attractive. And then I continued to create a triangular pattern on the leg of the drone to further beautify the spider arm part. After I drew a 2D drawing, I converted it to 3D. Not only that, I have designed the spider arm into a more complex look. Using the tools provided in the SolidWorks, I used fillet tools to curve all the constructed triangular part, which is on the sharp sides. After that, I added 2 more shapes in the spider arm, which is this part and also this part. Then I removed a few parts here by using the extruded cut tool according to the proper size. For the finishing part, I used fillet tools and the chamfer parameter for this part. Okay, in this part also I put a small hole for the stand. Finally, the important part, which is spider arm, was pure.
My name is Choo Jia Xin and metric number J20A0659. Now I'm going to present the part 4, which is battery. Battery, by using a top plane, sketch a diameter of 71 mm by 34 mm. And next, we extruded it with 17.5 mm thick. In the next step, we use fillet features for 4 corners, and each fillet parameter is 5 mm. Select the fillet features again for the 2 faces and keep it with 1 mm. Lastly, choose a blue low gloss plastic color for the battery. In the next part, which is part 5, which is called as spinner. For the spinner, we use a front plane and sketch a connected 2D L shape and define the diameter, which is 8 mm, 14.5 mm, 11 mm, and 2 mm. And next, we revolve it and select the vertical line as axis. Next, we draw a big circle with a diameter of 9 mm and use hole wizard features to make a 4 position of hole. Lastly, we define some metal color for the spinner. That's all from my part. Thank you.
Hi, my name is Min Ling, number metric J20A0666. I will present 2 parts of quadcopter. It is spacer and electrical connector. To start with, select top plane, sketch 2 circles, and the length is 5 mm and 3 mm. Select extruded base, and the dimension is 6 mm. Last, the spacer is 10. Continue with the electrical connector. Select top plane and sketch 1 rectangle, dimension is 18 mm width and 24 mm length. Select fillet with radius 2 mm. Select the full rectangle. Select extruded base with the dimension 7 mm. Select fillet. Select up face and down face with the dimension 2 mm. Select the full rectangle. Apply red glow glass plastic color on it. Next, select side face of the rectangle. Select normal tool. Draw a center line in the middle and sketch 3 circles. Select 3 circles. Make it relation equal. Sketch 3 circles inside the circle and make it relation equal. The dimension of the outer circle is 3 mm and the inner circle is 0.4 mm. Select the extruded base with the dimension 4 mm. Select the 3 circles and apply polished copper color on it. Last, select the other sides of the rectangle. Select normal tool. Select center line and draw a line in the middle. Select corner rectangle and sketch the rectangle at the right with the dimension 4.5 mm length and 1.5 width mm. Make it relation equal with the center line. Sketch 2 circles, 1 in the middle and 1 at the left side. Select both outer circles, make it equal with the dimension 3 mm. Select both inner circle, make it equal with the dimension 0.4 mm. The gap between the outer and inner circle is 4.4 mm. Select extruded base and apply polished copper color on it. Finally, the electrical connector is done. Thank you.
Assalamualaikum and hi, my name is Nurul Asyiqin Binti Ahmad. My metric number is J20A0592. I want to explain about my part. Part A is pillar. First, select top plane and sketch the circle with dimension 2.5 mm. Extruded the circle until 3.9 mm. Select the circle face and sketch with use polygon. The polygon have bigger than circle. Select any side of polygon and select vertical to make dimension 4.5 mm. Next, extruded up to way from 2D to 3D. Next, select polygon top face and sketch the circle with dimension 2.5 mm. Extrude cut the circle and make inside the hole with 4.8 mm. Next, select again the top face of polygon and make circle. Draw the circle until touch the line of polygon and make a two line tangent. Select extruded cut and keep through all and select flip side to cut. Make a degree with 45 degree. Next, select the below of polygon. Draw the circle until touch the line of polygon and make a two line tangent. Select extruded cut and keep through all and select flip side to cut. Make a degree with 45 degree. Next, select chamfer and select the line of circle with dimension 0.3 mm. Next, make a metal part with polishing aluminium. Pillar is done. Thank you. Next part is part 9, is fan. First, select top plane and sketch the circle with dimension 1.5 mm. Select extruded boss and extrude it to 6 mm and keep line plane. Select front plane and sketch with use center line. Draw the center line diagonally. Select a origin point and line. Make a coincident. Make an angle with 1.3 mm. Next, select a center line and go to reference geometry and select plane and choose front plane. Select the plane and select normal. Click that the circle and convert entities. Now use spline and line to make a drone fan. Keep dimension with 63.5 mm. Choose sketch fillet to make a bend at the end of the fan and use parameter 3 mm and 5 mm. Use trim entities to cut any extra part at the circle. Next, extruded boss at the fan plane with use 0.3 mm and main plane. Next, select linear pattern and choose circular pattern. Select the fan plane and the body circle with 360 degree. Next, select the face and circle. Select the face of circle and select circle to make another circle with dimension 5 mm. After that, select the extruded cut and make through all. Next, select the fillet at features and choose chamfer. Select the inside circle with distance 1 mm. Next, select the appearance color for all body with clean low gloss plastic. Now the fan is done. Thank you.
Hi, Assalamualaikum. My name is Natrah binti Muhammad Sukri. My metric number is J20A0645. I want to present a part 10, which is motto. Firstly, select from page and then sketch. Then select line. After draw the line, define dimension all the lines. Second step, select line, then draw inside the first drawing. Then define dimension 1 mm for all line. After that, select line again and draw over the bottom corner. Select trim entities and trim part need to trim. Then select smart dimension and define dimension. After done, make the drawing, choose features, then select revolve boss and select line axis. So the body is revolved. After that, select top surface, sketch, then choose normal. Next step is select circle, then draw two circles. After draw the circle, select for construction, then choose construction geometry. Select smart dimension, then define the circle dimension for 9 mm. After that, select center line, then define it 9 mm. After done with that, select circle again and draw a small circle and keep the diameter 2 mm. After that, select circular sketch pattern and select the small circles. Set 4 for number of circles. Select circle and draw a circle again on top with diameter 6 mm. The next step is draw pattern. Select line and draw line from the circle to make the pattern. After that, select trim entities and trim the half circle. Select circular sketch pattern, then select the half circle and choose 6 for number of pattern. So these are the 6 of pattern that I drawn earlier. Next, select extruded cut and keep directions for 4 mm. So this is the motor body, they are almost ready. The next step is select the back surface, sketch and choose normal. Then select circle and click to circles. Select both circle and choose construction geometry. Define the diameter to 12 mm for inside and 16 for outside. Then draw 4 small circles. Select all the small circles and make a relation equal. Define the diameter to 2 mm. After that, select extruded cut and make the depth inside to 3 mm. So this is the motor aluminium cast body. After it becomes an aluminium cast body, go to appearance. In metal, choose aluminium and then in bottom, choose blue anodized material. Lastly, select the inside surface, then select copper and choose polished copper. So this is the overall plastic 3D motor.
Assalamualaikum and hi, my name is Syakirah binti Azman. My metric number is J20A0658. Today I would like to present a word installation board. Choose top plane, select center rectangle and draw the rectangle. Slash smart dimension and define length to 36 mm. Slash center rectangle, make at the center point and define length 13.15 mm. Slash both line and make equal. Slash all line and slash for construction. Choose the circle and put circle at each corner. Select all the circle and make equal. Define the circle diameter is 3 mm. Select the straight fillet and use 2 mm and slash all the corners. Select extrude boss base. Keep the thickness for the visual support is 1.57 mm. Step is select the side face. Select sketch number 2 to make USB port. Slash center rectangle and make the center rectangle at the top of the side face. Define the length 2 by 4 mm. Slash line and slash string entities. Slash sketch fillet. Make radius 0.2 mm. And slash choose the corner. Slash of set entities 0.1 mm and reverse direction. Extrude boss. Reverse. Select the sketch. Choose cover entities and 0.35 mm. Slash face. Slash circle and make some circle. Slash all circle and choose make equal. Click extrude cut and slash up to next. Choose perspective image to look real 3D. It's all for me to part distribution board. Next, I will continue elliptical unit. Select the top wheel. Click sketch center rectangle, the line horizontal and make equal. Slash smart dimension and define 0.65 mm. Choose sketch fillet and define 0.1 mm. And select all corners. Select extrude boss, extrude to 0.12 mm. Select linear pattern. Select this axis, reverse direction and bond 2. Keep the gap 2.54 mm and select the bodies. Select the bottom face. Select radial geometry. Flip plane 3.0 mm. Select flip direction and flip planes. Select number 2. Draw the center line. The line define 5.08 mm by 2.54 mm. Select sketch chamfer. Define 0.50 mm and select all 4 corners. Next step, select extrude boss. Define 2.5 mm and select reverse direction. Select the material. Choose the dark color to hide the pin. Click the pin and choose hide pin. Select liner pattern. Select this line exists and click reverse direction. Select body. Select the full body. Keep distance 2.54 mm and click find number of model. Insert. Click insert. Keep feather and slash combine. Select all 5 body and select tag and click OK. That's all for me. Thank you.
Next, I want to present part 13, electrical unit 2. For the first step, select top plane and sketch one rectangle. Then select vertical and horizontal, make relation equal. Select smart dimension and define 0.65 mm. For second step, select sketch chamfer and define to 0.10 mm, then select all 4 corners. After that, select linear sketch pattern, set 2.54 mm for x-axis and 3 for dimension spacing. Then select all the lines and keep distance 2.54 mm for 3 numbers. After that, select exit. For the next step, select front plane, sketch then select normal. Then select line and draw line to make 3 geometry. After done with that, make relation and select 3 point at the end point and select vertical. After that, select smart dimension and define 9.08 mm for first geometry at the vertical line, 14.48 at the horizontal line for second geometry, 6.54 mm at vertical line and 4 mm for third geometry at vertical line. Next, select fillet and keep radius 1 mm. Select all corners, then select exit. After that, select sweat box. Then select selection manager and choose closed loop, then select rectangle. Select selection manager again, then choose open loop, so geometry created. Then, next step, repeat same process until 3 geometry created. After that, select all 3-part geometry, then select material and choose copper. Next step, select right plane and define to 0.50 mm. Then select plane, sketch and choose normal. After that, select center line, then select center rectangle. Define the length 7.62 mm for vertical. From outer line, 1.27 mm and top horizontal line is 2.54 mm. Then select sketch chamfer 0.50 mm and select all 4 corners. After that, select extrude boss and define 2.50 mm. Then select color black. Then select linear pattern and select direction. After that, select body, set distance 2.54 mm and 6 for number of pattern. For the last step, select insert and choose features, then select combine. After that, select all bodies and select add. So after the all step, it becomes one body of electrical unit 2.
So I will continue for part 14, assembly electrical board. Okay, first we need to open the assembly window before we do the next step. And first we need to select distribution panel and open the 3 part, which is distribution board, electrical unit 1 and also the electrical unit 2. Okay, first I will make this 3 part, which is distribution board, electrical unit 1 and also electrical unit 2 rotatable. So it is easy for me to combine these 3 parts. Okay, next I will make a relation between 4 face, which is this one and also this one and this one. Okay, then I go to the standard main and select these 2 face, which is this and also this, and they will automatically combine these 2 things. Okay, actually we can drag this electrical unit 1 wherever we want, but I make it distance between this and also this 8 mm. Okay, next part we will make a relation between the electrical unit 2 and also the distribution board, and make it parallel, which is we click this face and also this face, then they automatically combine. From this, I will penetrate the electrical unit 2 on the board, and I will make the distance between this face and also this face about 8 mm. So actually it is already fixed and can be continued to the next part, which is part 15.
Okay, hi, it's my part 15 final assembly. So because of video time presentation, so I will short to say. So all the final assembly is made by the made function. So like for example, it's like face A and face B, then combined together we using made function to do it. Then after that, we doing the animation for this. Okay, so we use the motion study to doing the animation. So we adjust the animation by using motion study, then we adjust the time and the effect that we need to move. So that's all for this. Then after that, at the last video have the animation that showing the final assembly.